Okay, so I'm recording so that people can watch this who missed it or review it. And now I'll share my screen. All right. So let's go ahead and start. This is the Docker deployments or Docker Cloud deployment class. The idea here is that we are going to, oops, that's not the file I wanted to show. Here we go. The idea here is that we're going to talk about Docker, but we're also going to talk about Kubernetes and using cloud services for deploying Docker, whether it's on AWS or some other cloud service. The idea being that you can deploy Docker or you can run Docker locally on your development workstation, and you can deploy the same service to the cloud without changes. So what I want to do first is, since we've had some trouble in the past, I want you guys to be able to get started setting up Docker. So the first thing I want to do is go through the Docker setup. So if you don't have Docker installed, go ahead and go to this URL, or just go to docker.com and install Docker. What you want is the Docker desktop on Mac or Windows. On Linux, there's no desktop client, but no big deal. You can still get going. So you click on Get Started. It'll give you the link to download, and you can see you can choose Windows or Mac, whatever. You just want the stable version, so go ahead and download that. And then when you're ready, go through the installer. And once it's installed, you'll have a little Docker desktop icon, either on your desktop or on your control panel here at the top on my Mac. So what I'd like you guys to do is work on downloading and running the Docker installer. Well, I just take a few minutes to talk about Docker, the different, what Docker is, what it's used for, why you want to use Docker, why you might not, or whatever. Anyway, so what is Docker? And forgive me for the crude layout. I'm not really a PowerPoint guy. I just use a text editor and use some Markdown. You can also follow along with my documentation here. Let me X out of this reading view. So I have a GitHub repository with just the documentation I'm going through. I'll paste that into the chat as well. And anyway, on github.com/FijiAaron, training Docker deployment is the URL. And I'll paste that into Slack as well for those who are listening or who are on Slack. Looks like we've got quite a few. We've got Srinivas, Nivena, Oscar, and Sawa all on the Slack channel. If you need help joining the Slack channel, just ask in the Zoom chat. Sawa and Nivena are great helpers, but anyone else, Oscar or Kalen, might also be able to help you get into the Slack channel if you're having trouble. All right. So while you're downloading Docker, let's talk about what Docker is. And I have it here. I don't know which you prefer. I could go through it on my text editor, or I could go through it here in this, and I can even go to the reading view, which might make this a little bit easier. So looks like there might be some formatting issues in my Markdown. All right, what is Docker? It's a tool for, let me make the font a little bit bigger maybe. There, that's a little bit better. It's a tool for running applications in an isolated environment. And by an isolated environment, I mean a Docker container. Docker is a tool that's based on keeping everything out of the kernel. So there was a tool in Linux called changeroot, or in FreeBSD, BSD being an open source Unix distribution. There's several FreeBSD, OpenBSD, etc. Anyway, they had something called changeroot jails that things could execute independently, and if there were vulnerabilities in one application, say one application, that it wouldn't affect another. And this was great for shared hosting environments because everything was independent, and you would just install the applications you needed and the tools and libraries you needed and go, and it would work in a fairly isolated way. Docker is based on this early work. And there's actually something called LXC, which is Linux containers that Docker was originally built on top of. It's since become independent, and there's various other ways of doing it. But the whole idea of containerization is to have these applications running independently. And Docker is definitely the most popular and predominant version of running that. Docker works in tandem with tools like Kubernetes. Now, Kubernetes is a tool for essentially running your own cloud, for orchestrating and running a bunch of containers together. So you might have a web server, you might have several microservices, you might have a database or a pool of databases, and various multiple services working together. And Kubernetes allows you to deploy, orchestrate, and manage those services. And we'll talk about that later on. Anyway, so what is Docker? It's, or not what is Docker, what are the advantages of Docker, right? Number one, consistency. I just need to clear out my Zoom stuff. Zoom is not great for working while you're presenting because it covers up part of your screen. Anyway, everything you run in a Docker container runs, whether it's in development or production, it runs on the same environment. And you see the little symbol is a whale with all these squares on top. It's based on the idea of shipping containers. Long time ago, longshoremen would manually load everything up piece by piece onto a ship and try and make everything fit. Well, once upon a time back in the 50s or 60s, someone got the idea, well, what if we had a standard container size and we could just stack them together? And that's how container ships happen. Well, that's kind of the same idea with Docker. What if we had all these standard containers that we could use to run our applications on and then just stack them in the cloud and deploy them so that if you have multiple web servers behind a load balancer, rather than trying to independently configure all of them, you just create a pool of worker nodes that register and can do that. So when you develop within a Docker container and you deploy to production on that same Docker container or based on that same image, that you don't run into the problem that I've seen so many times in testing, that it works for me, it works in development, or it was working in production and we can't figure out how to duplicate that in a new environment. So consistency is the first advantage of Docker. I'll take a break now, and before going on to the rest of this, I want to just touch base with everyone and see, is anyone having trouble downloading and installing Docker? No?
Yeah,
No.
Okay,
I have a Windows 10 Home Edition, but I'm unable to install Docker Desktop for Windows. So is there any alternate way? This is Satish.
Okay, so Windows 10 Home doesn't let you install Docker? Is that what you're saying?
Yeah.
All right. I don't have much experience with that, so I can't answer your question right now, but maybe as a group, we can take that offline and help you figure that out. Who is that?
Satish.
Satish? Okay.
I guess Windows doesn't support the Docker, so I think it's good.
So Windows does support Docker, and you need to install Docker Desktop. I don't know anything, if there's anything specific about Windows 10 Home.
Yeah,
we can
it
investigate
supports
it separately.
Windows 10 Professional Edition and then Education Edition, not
Okay.
Home Edition.
Okay. So that may be a limitation, but there's things you can do. For instance, you could set up a cloud system, whether on AWS or Linode is something I use, and you could run Docker. You could remote into that machine and run Docker from that machine. Since primarily what you'll be using Docker is from the command line, so from the terminal.
Okay.
So it is possible, although it may require some setup, and we can discuss that later. But let's go ahead and take that line and take that offline, and we can investigate that separately. The second advantage, and I mentioned this kind of at the start, is security. Docker is secure because it isolates your applications. Now, a lot of the advantages that Docker has are also come from using virtual machines. Virtual machines also can be consistent and secure and can be duplicated easily. There are a few advantages that Docker has over virtual machines. One is that it's more lightweight, and I'll talk about that in a minute. Another is that it's faster to deploy. So that's what I wanted to mention. The simplicity, it's easier to get started, I should say, without complex setup and installing dependencies. When you set up a virtual machine, you're just getting a base operating system, and you still need to install the apps you need and deploy whatever service you're going to run on that. So that's one nice thing about Docker is that a base Docker image can have everything you need baked into it. It's both like a virtual machine and like a configuration management system. And then with speed, a VM can take minutes to start up, to allocate disk space, to install the base OS image on top of the hypervisor, and so forth. Docker containers can start up in seconds or less. There's still a download factor, but since you're not downloading everything with a Docker image, that it can go a lot faster, and we'll get to that. And then lastly, efficiency. Now, VMs, like Docker containers, also allow you to share hardware. Hardware is at the point now where, despite our best efforts as software developers, you can run on a single server quite a few different applications. Now, you want to be able to run them securely, which Docker containers and VM allows, but you also want to run them efficiently. And Docker is more efficient than containers, and certainly more efficient than running on bare metal hardware. So here's what I wanted to point out. A VM versus a container. A VM has this stack. It starts with the base machine. You have your host OS running on it. And for things like VMware, it might be lightweight, or for KVM. The host OS being the OS that runs your virtualization. So we have VMware, we have KVM, which is a Linux-based system. We have Zen. There's quite a few others, but those are the big ones. And those are the hypervisors that run on top. The hypervisor allows you to virtualize the hardware and run the host OS. So then you have the individual VM OS kernel, right? And whether it's Linux or Windows or whatever. And then you have the associated libraries and tools that are needed. And lastly, you have the apps that you want to run sitting on top of that stack. This dotted line here, I'm not a graphic artist, but I hope this makes sense. This line represents the lower part is the infrastructure, and the upper part is what's needed for the VM. Now, going to Docker containers or other containers like Docker LXC or Rancher Core OS, those sorts of things. You have your bare machine, you have the host OS with a single kernel, a Linux kernel for all practical purposes. And then that shared kernel has each independent environment totally isolated, which has different libraries and tools for that container. And the userland tools, whether it's Bash or your libraries, your glibc or your Python or Node or Ruby environments, your applications like your database and your web server, and then lastly your tools. So anyway, you can see just by comparing this, there's the extra level of having a separate kernel for each VM, and there's the extra layer of having the hypervisor to manage multiple VMs as opposed to just the shared operating system Linux kernel with containers. So that's where efficiency comes in with Docker. Now, we've kind of gone through the why of Docker and the what, I guess. I want to check in. We're at about 15 minutes, and I'm hoping everyone has Docker installed, because the next thing we want to do is get our hands dirty. Is everyone ready, or does anyone need more time to install?
I'm good.
All right, let's go.
Right.
Download.
So if you have Docker installed, you should be able to look at your Docker desktop, right? But before we do that, let's go ahead and take a minute here. You can sign in, or you can create. If you have a Docker account, you can sign in here. Mine is Fiji Aaron. I don't know if I even know my password. I'll take a couple of guesses. No. Third time's a charm. Okay. But Docker is primarily a command line tool, and I've got a bunch of stuff where I was up here testing. I'm just going to close these out. Let's go ahead and terminate that. I probably just killed the Docker container or something. Anyway, so here I am on the terminal, and the first thing you want to do is just type Docker, and this will tell you if you've got it running. And it shows me all the help commands for Docker, what I want to do. Another thing you can do is you can do Docker version, and let me make this font a little bigger so that it's easier to read. How's that? Well, that's maybe a little too big. So Docker version, and let me increase, well, instead of increasing the opacity, I will try and slide it over to another window. Well, it looks like I still need to make it more opaque. Give me a second here. I know that's probably hard to read with that clear background. There, that's better, isn't it? All right.
Yeah.
So here we go. You've got Docker version 1903. So Docker 19 is the most recent. As long as you're fairly close, 17, 18, might be a year old, it's probably still fine. Did anyone, let me ask, I know Trisha, you have experience with Docker, so you've probably already got Docker installed. Is that correct?
Yeah, that's correct.
Anyone else have experience with Docker already, or already have Docker installed? I did send out an email last night, or this morning for those of you in India. Okay, Shashank, great. Anyone else? I'm just looking on the Zoom chat, and I'll go to the Slack if anyone wants to reply there. Okay, Altamash, great. Already you have it installed. Who here does have experience with Docker? I wouldn't be surprised if someone here has more experience than I do as well. As a user, I can load a Docker container and use it as a developer. But this class is going to be both a teaching and a learning class for me. I'm going to learn as I go, particularly when we delve into things like Kubernetes and orchestration and configuration management. All right, great, Oscar. You can help me too then. All right, so first thing is we've got Docker installed. Oh, and by the way, let me hop back over here. In the GitHub, the training Docker deployment GitHub, I'm going to be working off of the Docker setup directory now. So we've got the link to get Docker, the link to sign up for Docker Hub. So while I'm talking in general, you can sign up for Docker Hub if you don't have an account. That's why I was asking if you've used Docker before, you've probably signed up for Docker Hub. This allows you to search for Docker images to install. And then we can look at what we just did. I typed Docker version 1903, Docker info, which is what I'll do next. It's kind of like a longer version of the Docker version. It's got a bunch more information, just a way to test your Docker deployment. Anyone have trouble doing these, running Docker from the command line, just getting Docker version or whatever?
I don't have. Anybody have?
Okay.
I just opened an online Docker.
You just what? Oh, you've got an online Docker?
Yeah.
Is that Satish who was having trouble?
Yeah, yes, correct, Aaron.
Oh, awesome. So you can go along with like a cloud Docker service. I meant to try and pick one for people to suggest, but I also wanted you to get set up on your local environment. And maybe that's just me because I have unreliable internet and I want to work offline as much as possible. I want to be able to work whenever I'm offline or whenever my network is flaky. Yeah, Trisha is saying anyone has not yet have Docker installed. She's open to help. Okay, so the next thing we want to do, we want to
download it.
Yeah, great. We want to run a Docker container, and it's this easy. You just type Docker run, and then the container name, there's a default hello world container. It actually installs a minimal Linux container, and you can see I already have it installed. It might take several seconds for you to download and install that. It's a lightweight container that just all it does is say hello from Docker and print this message. This message shows that your installation appears to be working correctly. If that does work, then that means not only does the Docker command line work and it's in your path, but that you have successfully downloaded and run a container. So let's actually try this next example here, which is to actually run a Docker container and work within the Docker container. So you can just grab this line, Docker run it, Ubuntu bash. What that'll do is that'll download Ubuntu and run an interactive bash shell. And for me, I already have it downloaded as well, since I actually did a little bit of due diligence today, unlike sometimes, and I tested out my examples. And by the way, also in the documentation here in the Docker setup, it has that example. If you do have limited bandwidth and you don't want to install Ubuntu, which is going to be, I think, about 200 megabytes unzipped, about half of that zipped up, you can just run Alpine. Alpine Linux is a popular distribution for running Docker containers because it is very lightweight. The entire thing is something like 30 megabytes. So you can run Alpine. What's going on? Oh, it won't work because I'm already in my Ubuntu Docker container. So I can actually do here, I can cat etc lsb release, or I can type uname -a to get the information. And you can see here I'm running a Linux Docker container inside of my Mac host, and that's pretty cool. And if I go to Docker desktop and go to my dashboard, I believe it will show my running containers. Looks like I've got a lot. So you can see it's got all these weird names: Jolly, Diffie, Gifted, Matsumoto, Inspiring, Poitras. If you don't give your Docker container a name, it will make one for you. So from the command line or from my desktop app, I can stop a container here. So you see I hit the little stop button here, and it actually did the equivalent, typed exit within my Docker container and closed it. Now, a Docker container typically runs a single process, and when that initiating process is running, the Docker container will run. When that process exits, the Docker container will stop as well. So it's a good practice to only run a single application within a Docker container, and then to use multiple Docker containers to work together: a database, a web server, a load balancer, that sort of thing, to have each one in their own container and orchestrate them to work together. Now, with VMs, that adds a lot of overhead. But with containers, since they're all running on the same base OS kernel, and it's just the libraries and tools running on top of it, there is some duplication. For instance, if you have an Ubuntu container and an Alpine kernel, well, they're both going to have separate core libraries, and they might have separate applications also installed. You know, they, in that case, they won't actually have the same version, but you could have multiple different containers based on Ubuntu, and there's going to be some duplication of the user land tools and the shared libraries, but that's a good price to pay for the security and the ease of use of using containers. Sometimes it doesn't make sense, but anyway, so I have these other ones here. I can delete a container from the desktop app. I can delete my Hello World app if I wanted, etc. All right. So the next thing, I'll hop back over to my documentation. By the way, was everyone able to run a Docker container, not just the Hello World container? Okay. Oscar says, trouble executing on Windows with git bash. Oh, that's a good tip. Win pty docker run it. Okay. Now, that -it isn't actually it, although I always call it that. I think most people do. Yeah, thanks, Tricia. Raise your hand is a good option to ask. And then also Navena and Salwa are here to help keep me in line if I get off track, or if someone has a relevant question or comment to interrupt me without everyone having to interrupt the whole class. So feel free in Slack or in Zoom to ping them as well. All right. So I'm going on the assumption that everyone is getting that working. Oscar, with that point on Windows, since I don't use or I haven't used Windows in a long time, if I have a Windows machine, I'll be glad to do things like troubleshoot issues, Satish, but I don't know too much about it, and I can only share what I know. All right, so the next thing I want to do is introduce Docker help, right? So you can see there's a list of commands for Docker. Run is, of course, one of those commands, if I can find it here, to run a container. You can also stop a container or pause it, which will, instead of stopping it, it will stop the process that's running the container, and it will, you know, serialize the memory. It's like putting your machine to sleep. But let's look at the Docker run. So if I want to find out Docker run -- help, this will tell me the options for Docker run. And then what we'll see here is -I means interactive, that you can interact with it. Normally, you're not going to run a Docker container interactively unless you're developing. But for the example purposes, we want to run in the bash shell. And then the other thing we want to do is -t. So -I and -t, Docker run -I, or -t and -I. You can also put them together, IT or -IT. Excuse me. That means to run it in a terminal. So I can run Alpine. I can also give it a name. I can call it my container. Oops, I think that's 2 dashes for name. So anyway, when I run this container, oh, it has to be before the container name or the container image name. Let's try that. 3rd time's a charm. Okay, great. And I can see, what is it? OS release, Alpine Linux. And so that's just what I just wanted to show you, was how to see those options for that. And we're going to see some other options, and I can exit out of my container here. I guess what I wanted to do also was to show you, it's already in use. So I'm looking, here's my container here, and I can even delete it from here. So let's look at the command line. So besides Docker run, there's also Docker images, which will show you what images you have installed. I think you can probably get that through the desktop as well. I never use it though. So images, I have these. I have Nginx. I have Debian, Buster, Slim, which is a nice lightweight. You can see the size of each of these containers as well. So to run Debian is 69 versus running Ubuntu. Wow, I didn't know that. Ubuntu is actually taking up less space than Debian. That's something I'll need to consider. Alpine, look at how small this is, 5.6 megabytes. It's really lightweight. Yesterday in the Python data science class, some of the people were having a lot of trouble getting started because we're using Jupyter notebooks for working through the problems in the data analysis with Python book. And what I didn't realize and didn't have time to prepare for was we could have just used Docker containers to run a Jupyter notebook. So for instance, I could Docker run I think it's 8080. And I might have something else running on there. All right. I'm not going to worry about that right now.
Aaron,
Okay. Yeah.
there is a typo in Jupyter.
Oh,
With
thank you.
P, extra P. Okay.
All right. That's probably not important, but yeah, I'm not going to worry about running that right now. But anyway, we could use Docker containers so that everyone in the class would be able to, if they get Docker installed, be able to run Jupyter notebooks without having to set up their workstation to set up Python and Anaconda or Conda and to install all the Python data science libraries like NumPy and Pandas and scikit-learn, all those things. So that was a revelation I had preparing for this class yesterday after the Python class, which didn't go so well since so many people were having trouble with their setup. But great work, everyone, today. No one's having trouble, at least with their issue. Altamash, did you have a question or comment?
Aaron, just one question. So it's great that we can actually, use the pre-set up environments. But how about the integration? So let's say if I had to call this Docker command, let's say I have a Python script and I'm calling it via pre-installed Docker container, but I want to trigger that Python script for something like let's say a Java code. Okay, so do I have some command line arguments for the integration part with any different, outside the Docker container? Can I trigger it still?
I'm not sure what you're trying to do. So you can communicate one Docker container with another through a network interface. But you can also communicate with the host system. You can, for instance, mount a volume on the container to a file directory on the host system so that you can read the files on the host without having them on the Docker container. But the Docker containers do run isolated. They're meant to run as microservices or as independent machines, virtual machines. They're not machines, they're not virtual machines, as independent containers. The whole idea of doing a deployment with Docker is you have all these pieces working together that are all isolated, web servers, databases, etc.
Okay, so let's say let's say we installed a Ubuntu environment. They have a particular shell script, for example. If I'm triggering that from the Windows host command line, is it possible to trigger it with a single command and get the output?
Yes. Like so say there was a Python command, right? Or a Java command, whatever. You could get a container that has those dependencies. Like, for instance, if you're on Windows and you don't have Python installed and you don't want to configure Python, and if your Python is going to be different than the Python that some other developer running on a Mac is using, that's exactly what you do. You would just do Docker run, and you might run, there is a Python specific container, right? So let me just create a Python command, right? Let me see. I think I can just do, will that work? No, I'm not sure how to write an interactive Python command, but I'll just sudo it. What's that?
You need to go to the Python version, and there you get that, like, you get the interactive terminal wherein you can type and check whether Python.
Exactly. So I might even be able to do that on my Ubuntu. If I didn't accidentally delete it, I could actually say Python command.py, right? This is the command. So I could execute Python directly, or as you said, that was Trisha. I could go into a terminal, and I don't know if Python's installed, but I could create a container just by, actually, let's go on. That's the next step I wanted to show. Well, it's not quite the next step. Let's get to that in a minute. I have an example running a web server with Nginx. So if you want, what I wanted to point out next is if you want to get or fetch, you pull a container. So rather than Nginx, let's go to Docker Hub, right? And let's find a Python container. And there's probably an official container from Python available. Here we go. So you can get, so Buster being a Debian release, Alpine. Yeah, let's go ahead and, well, let's not get the alpha. Let's run a lightweight Alpine 382. So we're going to grab this one. Well, we don't need to look at the, let's look at the Docker file. Here's the Docker file. A Docker file describes your Docker image, and it's how you build it. So it says from Alpine 310. So using the Alpine Docker container as its base, build this image from that one. Sets the environment, and then it does APK. So what it's going to do is it's probably just going to, look, it's what it does is it downloads Python and runs it. Let's not look at this one though. Let's look at the Ubuntu one, which is going to probably be a lot cleaner. So 3.0 Slim Buster. Well, this is Debian. So from Debian, Buster Slim. It says apt get, update, and install the certificates. Set the Python version, set the GPG key, set all these paths. So it's downloading and extracting Python. I was looking for one that that actually just does apt get install Python. But anyway, so here I am in my or wait, this must be Ella. Wait, I'll just do uname. Okay, so this was my Ubuntu one, right? Yeah, okay. So what I'm doing now is I'm simulating what we're going to do in our Docker file. What I want to do is I want to apt install Python. Unable to locate package Python.
Aaron, maybe you need an update. Yes, an update first.
Yeah, probably.
And this is Alpine?
No, this is Ubuntu. I just wanted to make it simple for that. Okay, so now let's do apt find Python. It may be unusual because it may have so like it might not have apt as a alias for apt get.
We need to do apt get.
What is it? Apt search.
Search. Yeah.
Search. Okay, thanks.
But without get. Yeah.
There we go. Thank you. I'm a bit rusty with my apt stuff. All right. What have we got here? I didn't want to do a full. I just wanted to get package names. Yeah.
I have a question. For example, when we run the hello world example
Yes.
with the docker run command, and what is the difference with pull? Because run search the image and store in the the local machine.
So Docker pull will download it, but it won't run it. I think I started to say that and didn't complete my thought.
Okay.
So for instance, I could do Docker pull, whatever's latest, right? There's probably recommended. So 382, I could just do Python latest. So I could do Docker pull Python latest. And what I was trying to do is not depend on the network here. This apt search isn't helping me. So I'm going to abandon that Ubuntu idea. But the idea is that you can use, this is what you would do in practice actually, is rather than build your own Docker image that installs Python, you would grab a base image like this Python latest, which is going to run on, what does it run? So it's going to run on Buster or on Windows with Windows Server Core. Buster meaning Debian Buster. So Debian 10, I think. Okay, so while that's downloading, while it's pulling Python because of that example, let's go back and look at what we're doing. So Docker pull, I wanted to run this in parallel to illustrate something. So hopefully that won't suck too much of my bandwidth. But what I'm doing is I'm installing the Nginx web server. And then the next thing I want to do is show you how you can mount a volume and then create a Docker image. Okay, so Nginx installed, so I can do Docker run Nginx. Now, there's something else I need to do. I need to specify a port, right? So let's do Docker run -- help. So there we go. So publish a container's ports to the host with -p. That's what was throwing me off. -p, I think of it as -port, but it's publish. So it looks like that that Python one is still running. So what I want to do is I want to Docker run Nginx. I can do Nginx latest, but I'm just going to specify Nginx. So Docker run Nginx -p. Now on my host machine, I actually have an Apache web server already running. So what I want to do is run on port 8888, and then so what I'm doing -p is saying take port 80 on the container and forward it to port 888 on the host. And I need to put that before the Nginx. So Docker run Nginx like so. And now that that's running, what I'll do is I'll go to localhost :80 or 8888. That's not, oh, well, it's not working because I can't type localhost. All right. Now, oh, it looks like I've already got this running. So let's run this on a different port too. Oh, it's running because I ran it from. So I'm gonna do it on port 9999. All right, let's try this again. I've got something else already running on 888. All right, so we've got welcome to Nginx. It's running an Nginx web server. Now, what I wanted to do next was show you how to create a Docker file with Nginx. So what I'm going to do is I'm going to make up, well, I'm going to call it my site. All right, and I'm going to go to my site. And then I'm going to create a Docker file. And I'm just going to use Vim. Now, the Docker file describes your Docker image. And you saw a little bit before, what you want to start off with is you want to start off with a base image. So from Nginx, latest. So that's the base image. I'm building mine from that one. What I want to do now is I'm going to copy a folder called source to, let's see, I need to look at my documentation here to see, okay, I'm just gonna paste this, copy source to user share Nginx. So this is, for this image, this is the web root folder for that app. And I'm just going to paste that in there. And then I'm going to expose port 80. The web server runs HTTP port 80. And that's about as simple of a Docker file as you can come up with. I suppose just from whatever would be the simplest. So what I'm doing is I'm doing this run. The run commands and so forth are the meat. This is the configuration management. What I'm doing is I'm copying source from the host to this directory. All right. So I'm going to save that. And now I'm going to make my source directory. And I'm going to create an index file. And you can see here in the documentation, I just have echo this into whatever. So, but I'm just going to edit that and just have it say hello Docker. So this is my website, right? This could be however complex of a web app you want. It might be tied to another Docker container that points to a database. It might have a load balancer in front of it, and it might be running several instances of this web server. Since Nginx is a reverse proxy, sometimes it serves as a load balancer in front of others. But anyway, so I've created a web app on my host machine, right? And I can run Node.js, right? I can run a Node server. And what port is this going to run on? 8080. So it says hello Docker. So this is running on my host OS. Now I want to run it on my container. I'm going to go ahead and kill that. So now I'm going to I've got my Docker file. What my Docker file is going to do is it's going to copy the source folder in the host OS to the Nginx document root, whatever that is. So user share Nginx HTML. And then I'm going to expose port 80 on that container to my host system or to the internet. Well, to my local network. Now, the next step is, let me go back to my documentation here. I'm going to build my image. So there's three levels you want to think about. You have your Docker image, which is defined in your Dockerfile. Then you have a container, which is running. And then you have different instances of a container. So let's go ahead and look at this. So I have Docker images. I have all these ones. It looks like my Python is finally installed. I have Nginx. I have Debian, Alpine, Ubuntu, my Jupyter Notebook, NetHack, in case I need to play some command line games. Then I have this Nginx node one that I was working on a while back, and the Hello World one that we just installed. So now I'm going to build my Docker file. So I just Docker build, and I give it a name, right? So -t is my container. And then dot, because I'm in the directory where my container is defined with my Docker file. So it's building it, cannot stat source. Did I do something wrong? Yes, apparently I did do something wrong. Let me look at that Docker file. Copy. Oh, you know what? I probably need to put it like that. There we still cannot. What the? Oh, I need, the other thing I think I need is maybe I need a full path. Vector source. Anyone see any obvious typos in here?
Can we just, yeah. Okay, SRC is present, so.
All right.
A question, Aaron, do you add the SRC folder will be copied to what path?
Yeah, it should be.
That destination exists already in your machine?
Yeah,
Yeah.
that's it.
Yeah, I'm not sure what's going on. I just wanted to illustrate how to do it, and since we're running a little bit low on time, rather than try and get that up just so it says hello Docker in the container, I'm going to pass that up and figure out what I did. There's probably a typo somewhere that I'm missing. But let's go ahead and we've already. I think
I know the error. Maybe.
Yeah.
Maybe you need to add -r because it's a folder in the CP.
Oh,
CP.
that may be it.
Maybe is that dash R after this. Maybe I don't know.
Yeah, maybe, but I don't think so because it's saying it can't stat source. But anyway, I don't want to spend too much time on this because that is.
I think the file is not existing in the container, and the second path what you are giving is a container path.
Yeah, the first path though is the non-container path.
Yeah, and in the container, this particular path is not existing, and it's just trying to find this path: user share Nginx HTML, and then paste it. But it doesn't have that.
Okay.
So instead of this, if you give a dot, it will work.
So let me just Docker Nginx. So I think I actually just copied this from this example here. So quick reference, copy. Maybe I don't want the slash on the end actually. Maybe that's my mistake. We'll give it one more try. All right, and let's see, user share Nginx HTML. Okay. All right. All right, I was seeing if I had another copy of that right now. I've got a PHP example here. I'm just going to try and do this. So Docker build T. All right, so we're doing PHP. Don't tell my mom. So now what this is doing is this is reading the Docker file for this one, and you can see it's almost identical. I'm baffled why that source isn't working, and sorry for the confusion. But anyway, yeah, from PHP Apache, copy source to var_w. All right, that is really weird. I don't know why.
But you use copy.
Copy instead of CP, huh?
SP.
Well, there we go. Rather than run, thank you. I feel embarrassed now. All right, where are we at? No.
Don't worry.
Yeah.
About that.
Thank you. Where did I put that container now?
It's in the. Yep.
Well, no, now I'm in the temp directory here for this. I didn't push it. Here.
Yeah, I understand.
Okay, so yeah. Oh, that's what's going on. The source directory is in the wrong spot, but where is my Docker file? Did I call it my site? Oh, I did. All right, so rather than run CP, thank you. Who was that helped out? Was that Oscar?
Yeah.
All right. Let's see if it'll run now. I've got too much. Okay, Docker build. What is it? Is it name or no?
Minus the container.
-t. Thank you. My container. Dot. Well, that's so much better. Now I can do Docker run -p 9999. I think I need a space there. Except I might have left that one running, dangling somewhere. Port 80, and not run Docker run. I've got myself all flustered now. Not Nginx. My container. My container. Looks good so far, unless it's already running localhost 9999. Site cannot be reached. Well, another typo. We still got welcome to Nginx, so I think it's the port. We'll just run it on port 9000, unless I have too many web servers running. There we go. I got it. Hello, Docker, right at the end of the class. Okay, so what I want to do is touch on briefly how we can look at our containers. So I'm going to actually leave that running and then open another. So what I can do is I can do Docker container or containers ls. That will list my containers. So you can see here I have my container running. And it shows the ports. So because I didn't give my Docker container a name, it created one for me, Nifty Hellman. You can see the image is called my container. The command is that. It's created 12 seconds ago, and here's my port forwarding. Now, I also wanted to show you how you could change something. So for instance, here, I'll just open one more terminal. What's one more terminal out of 100, right? So for development, what I want to be able to do is I want to be able to go to my source folder, and I want to be able to edit my app, and then, so maybe I'll have that say, hello class, common Docker, sure. Now when I go here and reload this, it doesn't reload because it's not in the container, right? It's in my host system, but it's not in the container. Remember that big mistake where I ran it separately. So what I'm going to do next is I'm going to do Docker stop my container. I need to Docker stop this instance, Nifty Hellman. Or remember, I can go to the Docker desktop and find that one and hit stop here. All right, so that stopped. I go back here and we can see that that exited, or well, that's the Docker ls. This one exited my Docker run. So what I want to do is I want to do -v. -v will create a volume, and I need to have a full path. Users Aaron. Now I wish I would have done this in the temp directory. Training, Docker cloud deployment. My site. Nope. I've got, oh, what an ugly path. All right. So what I'm going to do is go like this. I'm going to copy my site to temp. Copy -r. All right. I'm aware it's the top of the hour, so if anyone has to go, that's great. If not, I just wanted to show you how to add a volume and take a couple more minutes to talk about a few other features, viewing images and containers. So if you're leaving now, I appreciate your time, and I hope to see you back next week. If you're sticking around, I'll spend just a couple more minutes showing you how to mount a volume so you can use development, and then I would love feedback from anyone on what we can do to improve the class and what direction they'd like to see going forward. So run -p 9000 80-v, oops. So -v is the volume. Now I can just say, oops, temp my site. Oh, looks like I actually copied it here. That's okay. Temp source, and then colon to what is it? Var. I'll find the information here. User share Nginx. So rather than just copying it, I'm actually going to mount a directory on my host, and it's doing the Linux mount command. That it's mounting it as a volume. So what I'm doing is copying source to HTML, and then Nginx. Now that should be running again. Localhost 9000. Hello class Docker. Okay, so now what I'm going to do is I'm going to edit my index. I'm going to edit. I need to go to temp source. And I'll just say that's all. And now when I go here, it should reload. That's all Docker. So now I can do development in my Docker container from my host system. I can use my IDE or whatever editor or tools I have on my host system, and it's actually going to run within a Docker container, which the idea of it being that the Docker container will be the same as the Docker container image that's going to run on the production environment. So there's none of this. It worked for me on my workstation. I don't know why you sysadmins didn't get it working in production. Anyway, so that's about all I wanted to cover. Docker images shows you what images you have installed, as well as Docker container ls. Shows you what Docker containers are currently running. I believe that's all I had on the list of well, let me just I posted here on, there we go. That'll send me to the documentation. Docker setup. How did everyone do? Was everyone able to be able to run the Docker containers? I know that last example might have been a little, oh, the last thing I want to show is Docker remove an image or remove a container. But was everyone able to run Docker containers locally? Or in Satish's in the cloud? Shashank, great. Altamash, awesome. Oscar, yeah, you were a big help. Thank you. Satish, all right. Rough start, but you got it working in the cloud, right? Trisha, thank you for your help. Good job. Kaylin, what about you? Were you able to get a Docker container running? All right. Looks like we, Navena, were you just following along and helping out, or were you able to get a Docker container running?
We are not able to hear you.
Can you hear me now?
I hear you. Can you hear me?
Okay, great. I joined the class read-only just to try to figure out what I can use Docker for, so I didn't even try to install it yet.
Okay. Was it useful for you?
Well, I do have questions.
Great. Now, let's go ahead and take a few minutes at the end to have questions, but let's make sure. So we have a few more people. Sumanth and Miriam, I think you guys weren't here at the beginning, but were you able to follow along and create a container? Yes, it was recorded. I'll be posting it on YouTube.
Altamash is asking some question. I don't know.
Yes. What is that, Altamash?
Yeah, right. So actually, with respect to, let's say, hosting the web page, you showed a couple of examples. So one where you changed the content in the HTML file, it was rendered at the runtime, and one example where it was not rendered exactly. So what was the difference? I just want to understand.
The difference was that we were mounting a directory from the host computer inside the container. And that way, when I made changes on the host, it reflected in the container. It's like kind of like, you can think of it like as a symbolic link, but it's really a mount point, which is, it's a Linux term for putting a file system in a certain directory. It's usually used for network share.
It's kind of shared between Docker and the host system. So
yes, and the reason it didn't work at first is because that directory is not shared. It was just copied over at the start of when the Docker container started, right?
Okay, great. Yeah.
Okay, awesome. So I've gone through every class this week so far and asked for feedback and what each person's goals are. So if you guys are all interested, I'll just go down the list, and I asked if you were able to get it set up. But let's go ahead and everyone can take a minute or two, give some comments and feedback, or if they have questions that they would like answered as well. So we'll start at the bottom. Shashank, did you have any questions or comments or anything you'd like to see going forward in this class?
So no, this is pretty much like very interesting. That's why I wanted to learn this. Actually, I worked very little on Docker more than a year ago in my previous company.
All right.
So I wanted to learn it more. So that's why I joined this class, and I find this really interesting and helpful.
Did that help refresh your memory?
Yes.
Oh, great. That's right, Altamash. Docker is it's a Linux system. Hypothetically, you could install a Linux system with a GUI, and you could even run like a remote X server, an X client on the Docker container. But yeah, it's primarily for running servers is the main use of Docker.
Okay, but if I'm ambitious enough to want to run a GUI and build an image containing a GUI, that's possible, right?
I think so.
Okay.
Yeah, if I were you, if you wanted to experiment with that, I would search for Docker X server, like X Windows system. Because a Docker container is going to be a Linux system primarily, that's going to be your GUI. Kaylin, did you have any questions or comments?
Not particularly. I was just kind of following along. This is kind of all pretty fresh for me. I just use a good familiarity for me.
All right. All right. So your job is for the data science class to set up Docker containers with Jupyter notebooks for everyone. Okay. So we don't go through that issue where we spent the whole class installing. All right. Okay. Just kidding. Miriam, what's that? Kaylin, did you have another comment?
I was just gonna say no. It was nothing. I think so.
All right. Miriam, did you have any comment? I didn't see when you joined, so I hope you got you were able to follow along when you did. We can't hear you. Oh, go ahead.
Just to interrupt, Miriam is asking your YouTube channel or something. So I think.
Yeah. I've got it somewhere. Let me see on the Python channel. I think it has where the YouTube is. Oh, not on that one. Maybe on the Python test channel. Let's check that out. There we go. Yeah. Well, I guess it doesn't have the YouTube channel. I'll find the YouTube channel. It'll take me a day or two to get this uploaded. Maybe I'll get it done today. But welcome everyone. All right. So here's the channel. Okay, I'll paste this into the chat. And I'll also send the follow-up email. That's the YouTube channel where it will appear. Did you see that, Miriam? I'll paste that into the Slack channel as well.
Yes, sir. Okay. I got the link.
All right.
Thank you. I sent a private message to you to attend the other classes, but I didn't get.
Okay. You didn't get the invite? Okay.
Yeah.
Yeah, what I need to do this weekend is set up an online registration so we don't get mix-ups like that. I apologize. But ideally, if you go to training.oneshore.com by Monday is my goal, that you can then click on a class, enter your email, and register, and then it'll send you the invite automatically. This week has been so hectic that I have literally been dedicating a couple hours a day to trying to reply to people in email and LinkedIn and Slack and stuff. And really appreciate the help of those people who have been willing to assist with that, like Navena. All right. Who else? Satish.
I really appreciate your time to, share your knowledge. I want to, learn much from you. So that's why I ask. Thank you.
Yeah, it's fun for me too. That, like I said, that I know the basics of Docker and I know a little bit about Kubernetes, but not enough to qualify. So I'm hoping that this will be both a learning experience for me and a great way to network with you all and share our knowledge and experience together. Like Oscar helping me out with my stupid typos in my Dockerfile. Thanks. But anyway, Satish, did you have any comments or things that you'd like to say? I'm sorry, I can't hear. Is that Otabek? And I hear some beeping in the background.
No, not here. Maybe. Okay. So I was trying to say, like, find any other way available to do for home team, and it was really interesting to learn this with you. Thank you for the opportunity.
Okay. Yeah. Thank you. Oscar, did you have some comments for me?
First of all, Aaron, thank you for your time and thanks for sharing your knowledge. And
thanks.
It would be nice if we can define like a learning path with Docker, for example, using advanced feature like networking, communication, or implement Dockers in Jenkins. And it would be nice if we can learn along the time. Yeah.
Yes, that's planned. Next week, we're going to explore more Docker details, and going forward, we will talk about Jenkins. We'll talk about Kubernetes and Spinnaker. Spinnaker is a tool for doing continuous deployments on Kubernetes. And Kubernetes is an orchestration tool for containers, not just Docker, but other containers. It's ambiguous or it's flexible. And we're also going to be talking about how to use Docker containers with cloud services. For instance, take your container that you're developing with locally, push it to AWS or Google Cloud, and run that container in the cloud. That's part of the course title. So that's all going to be part of it going forward, as well as Docker Compose. We may try using Swarm before using Kubernetes because it's a simpler solution that allows you to deploy.
Okay, nice.
All right. Every class this week has kind of been a let's getting started, and then next week is going to be organization, and then it might take me another week before I flesh out the curriculums. But that's part of why I ask for feedback here to help decide how the curriculum's going to go. All right. Has everyone had a chance to talk and give their comments, or would anyone else like to make a comment?
I have a comment. It's Navina.
Yes, go ahead.
So like I said, I joined this class just read only because I have absolutely no Docker experience, and also my knowledge about servers and automated pipelines, virtual machines, and so on is very, very limited. So throughout the class, I was actually thinking about ways how a tester would use Docker. And maybe one of the ideas that came to my mind was for running test environments, for example.
Exactly.
And running automated tests on those environments. So basically my question was, if you can maybe say just a couple of sentences about that, about running test environments, or maybe leave it for some other class. And I would also be interested to hear what are other useful ways for a tester to use Docker.
So yeah, that's the primary one, is to be able to deploy a test environment, and it really has to do with how your organization works, right? If your developers are already developing on Docker containers, it's very easy to then just grab that image and run with it, right? You can test locally, or you can have your CI tool deploy to a Docker container. That's the real advantage, that it makes that process of setup really easy. And I think that's a challenge in testing, that you know, you have these artifacts, right? It's a website being deployed or an app, and you need to create an environment. And one thing that I have, you know, somewhat excelled at myself is I can recreate lots of different development environments. I've, you know, worked with lots of different platforms, so I know how to set it up myself, but not every tester does. And then you still run into that issue. Well, the way I set up this web server is different than the way it's set up in production, or the way another developer set it up. And so I'm getting different errors than they are, and it kind of invalidates the testing. So yeah, number one, allows you to locally run, or run as part of your continuous delivery process on a consistent environment. Number two, it allows you to create production-like environments, especially if your production environment is also Docker, that you can then create on demand a test environment that looks just like production. And there's, you know, a huge advantage of that, because it's going to find production style bugs. The one issue it often doesn't help with is production data is going to be different than test data. And then the third thing is that when we get into orchestration and deployments on the cloud, that it speeds up development, so that you can create and destroy environments on demand. It costs less, it's faster. And then finally, when you do deploy to production, when you're using a containerized deployment method, you can roll back or spin up more as needed. So if you go to production and you find your demand is higher than normal, you can, you know, build out more Docker containers fast, so that your users don't experience slowness or downtime. And likewise, if you deploy something to production that may have errors in it that you need to roll back quickly, because Docker deployments can be done very quickly and can be scaled, that you can then roll back really quickly as soon as a defect is found. And those are ways that Docker helps testing.
Great, thank you for that answer.
You're welcome. All right, I appreciate everyone's time, and I look forward to meeting with you next week as well. Feel free to communicate in the Slack channel, and like I said, I'm going to try and get the registration going, and get a forum or a mailing list going where we can all help each other and answer and ask questions. So take care, have a great weekend, good night for those of you in Asia or in Europe, and take care out there.
Thanks,
Goodbye.
Aaron.
Thanks, Aaron.
Thanks.